All right, Tai. So till the time she's joining, or let us just at least start with the basics of what you are, what is the basic structure of your class 12. So see, class 11th is over. In class 11th, most of you, most of the students of your batch had joined late, some had left, then some had rejoined. So all these things disturbed the whole study. Now what is happening? This is day one. So since you have joined since day one, so practice on the same day. Do the whatever assignments are given, they have been uploaded in the portal. Whatever questions I tell you to do, all these questions, do it simultaneously so that you are continuously in touch with what is the syllabus. All right, now you have sufficient time. Also class 11 last year started late also, so syllabus also was going it was lagging behind. Now since it's March only, you have sufficient time. So basically, before starting with the first lesson, let me tell you about the whole basic structure of the syllabus, what is present. You had part 1 book in class 12, in 11th, part 2 was there. Till gravitation, you had first book. Then again, it started with mechanical properties of solid, till waves and SHM. The way, similarly, you have the syllabus divided into part 1 and part 2 in class 12th also. So see, regarding the basic syllabus, firstly, you have a very huge unit that covers your first book, which is your electromagnetism. This is your first book, electromagnetism. Now, what all lessons are included in this? Firstly, you have electric charges and field. Electric charges and field. Electric charges and field you have. Secondly, you have electric potential and capacitance. Then these two lessons, these are included under electrostatics. Then when the charges begin their motion, now in these two lessons, you only consider when the charges are at rest. Now when the charges are in motion, when they begin their motion, then we get the lesson that we refer to as current electricity. Means now the charges, they have started their motion. All right, the charges have started their motion. So this lesson, this is known as current electricity. Yes, Aram, how are you?
Hi, ma'am. I'm good.
So how did your exams go, Aram?
Yeah, they were good. I scored 80 out of 100 in physics.
How much did you score?
80.
80.
Yeah.
80 percentage.
Yes.
Okay, very good. So now, Aram, in class 12th, at least 10 to 15% more you have to score, right? In your 11th class, you had such a good score. So I was saying the same thing to Tarif also, since it's your day one, practice simultaneously. Assignments, whatever assignments are given, whatever questions. In 11th standard, no, the session also started late and you had also joined late. So many things were there. So since it is day one, you have sufficient time. It's only March right now. So a lot of time is there. So simultaneously keep on studying, and whatever doubts you are having, you can I can take your doubts in the next class, or the best thing is that you can text me on WhatsApp also. You both have my number, right? So I was just discussing the syllabus that the way in your class 11th, you have part 1, part 2 books of physics. Similarly, here also in class 12th, you have. So in electromagnetism, electric charges and field, and electric potential and capacitance, these two lessons, these are basically, they are under the unit electrostatics, where the charges do not move. When the charges begin their motion, you get current electricity. After this, what did I say? Electromagnetism is the unit. So now magnetics component will also come. So you have magnetics, and chapter 5th is magnetism. So magnetics and magnetism. all these lessons are completely different from your class 11 syllabus, but basics of whatever you have studied in class 11th, vectors, all the parallelogram laws, all these things will be used here again. Fine, vector addition, whatever laws you have studied, all the basic integration, basic calculus, everything is there in class 12th also. So whatever you have studied in class 11th, not exactly it will be used, but the basic gist or the basics of the calculations will be used from class 11th. Then you have EMI, electromagnetic induction, and AC, alternating current. They are also included in this. And lastly, under electromagnetism, you have EM waves. So magnetics, magnetism, these are separate lessons. EMI, AC, these are also separate lessons. And EM wave, this is also a very short lesson that has to be covered. So a lot of weightage is taken by electromagnetism portion, not only for just your class 12 board exams, for your upcoming entrances, whatever entrance exams you will be appearing after class 12, that also electromagnetism has a very huge portion. Then you have the next unit, that is optics. Under optics, you have just two branches. One deals with ray optics. Ray optics means the glasses, mirrors, lens, that optics. And then you have wave optics. Wave optics is similar to waves and SHM, waves and oscillation, which you have just done in your class 11. Interference, some more phenomena will get added, like diffraction, all these. Many things from your class 12 syllabus have been deleted. All right, polarization and many more laws were included. Now they are not included. So most of the portions are there, but major small topics, they have been deleted. Then in the class 11th also some portions were deleted, so those will not be covering. We'll be just seeing it. So I'll be mentioning you which all topics are included, what all are not included. Then you have modern physics. In modern physics, you have dual nature of atoms and radiation. This is a lesson. So this lesson is very similar to your structure of atom, which you have done in your class 11th in chemistry, structure of atom. So this lesson is very similar to dual nature of atoms. Then you have, this is dual nature of matter and radiation. Then you have atoms only, specifically atoms. This was dual nature of matter and radiation. This is specifically talking about atoms. This is all similar to your structure of atoms, very much similar to that. Whatever you have studied in structure of atom, all those, they are included here. And lastly, you have nuclei. Now nuclei is a very small lesson. Radioactivity portion, all these are not now included. So nuclei is also very, so modern physics is a very small topic, very scoring topic, and it's easy. Theoretical part is also there, very less calculations are there, so you'll be able to manage it. And last unit is the unit of electronics. That deals with one single lesson is now included. Communication systems have been deleted. The whole lesson has been deleted. So that we are also not going to do, because no question is going to come in your entrances even. And from your CBSE board perspective also, it's not going to come. One lesson is there, that is semiconductors. So from semiconductors, you have PN junction, all these small topics are there that you'll be able to manage. Fine, so this is what is there in your class 12th whole complete syllabus. This is how the division occurs. Now see, marks are always divided on the basis of units. Fine, so you can see a very huge portion is taken by electromagnetism, and that is included in your first unit. All right, so I'll start with electric charges and field only. That is the first lesson of your physics. All right, wherever you are having doubts, as you already have studied with me, so I think this shouldn't be a problem. You can unmute yourself anytime you want and answer and ask your doubts, or chat box is always open for answering also, or for clarification of doubts. So electrostatics. Statics means what? Something that is at rest, something that is not moving, that is statics. So when the charges are static, the charges are not moving, that we call it as electrostatics. Charges are not moving, that is meant by electrostatics. So under this branch of physics, no, this is that branch of physics that deals with the charges at rest. Charges at rest. So two lessons are included. Study of electric charges at rest. First lesson is electric charges and field. And second lesson is electric potential and capacitance. Find electric charges and field, electric potential and capacitance. All these lessons are included. Now we'll not be using the terms acceleration for moving charges or the charges are moving at this particular speed. No. Till the time we are not stepping into current electricity, we will not be talking about the term charge moving. Whatever we'll be discussing, that thoroughly will be including the condition that charges are at rest. All right. Now, a very basic thing, electric field and electric charge. These are two major topics. So electric charge itself is a very huge topic in itself. So I'll start with electric charges and field. In this, electric charge term will come first. So what is electric charge? Charges you already heard of: electrons, protons, neutrons. All of you are aware of this, right? All these terms you all are aware of. This is not a new term for you. So how will you define it? See, some things are present in nature that have no definition of themselves, but they are the quantities that define other quantities. The way, if I talk about mass is an intrinsic property. You cannot define mass, but with the help of mass, you can define force, you can define acceleration, you can define momentum, other quantities, right? This is what you have studied in class 11th. Similarly, electric charge is also a very intrinsic property. Intrinsic property means a very basic property that has no definition of itself, but this property, that is electric charge, is used to define other quantities like electric force, electric field, potential. These quantities, upcoming quantities that we'll discuss later on. So these are defined by electric charge. So if I talk about, let's say, force is made up of mass into acceleration. Then acceleration has velocity and time. Then velocity has distance and time. Like this, you can keep on breaking it. So very small unit at the end is obtained, a very small physical quantity that is building up and making all these huge bigger quantities. Same is the case of electric charge in your electrostatics. Electric charge, these are very basic quantities without which no electromagnetism phenomena can occur. So these basic electric charges, these give rise to various huge phenomena which are leading to the current and all the electricities and the flow of charges to happen successfully. So it's intrinsic property of matter which gives rise to various forces, various fields. What you have to remember is SI unit. SI unit is coulomb. Just write C at the end. The way, no, for force we write Newton, we write capital N for Newton. Similarly, coulomb, you write C. So this is written like this only. For example, 4 coulomb. So 4C like this. CGS unit is very rare for charge. It's not used often. We only have SI unit coulomb being used, nano coulomb, micro coulomb, like this. These prefix suffix will be added, but CGS units, these are not so much used. But for a CGS unit, at least you have to remember for your knowledge, CGS unit, this is electrostat unit, ESU, or somewhere in other books you will find it as stat coulomb as well. Stat coulomb. So both these SI units are available. And next thing, two types of charges. C class. Types of charges, all of you know, positive charges is one of the groups of charges. Second group is negative charges. So this was, can you just tell me one thing by your analysis? Do you think this naming or the categorization of the charges as positive and negative is because of certain bases on the basis, are they being divided into positive and negative terms, or do you think randomly they are just named as positive, negative? What do you think? Some basis or randomly?
Some bases.
Some basis. Sari, what do you think?
Basis.
Some basis. See, a general idea when we see the name positive and negative as two groups of charges, these are actually, we think that this is on a particular basis. As layman, this only comes into our mind. But in reality, this scientist, Franklin, he actually gave the term positive and negative. So this was totally random. This has no basis. Actually, it seems like this has certain bases as positive and negative, but this has no base. Basically, he observed that two types of behavior are occurring when the charges are experimented. So one group he randomly named it as positive, second group he randomly named it as negative. Later details were discussed. All right, so that is what you have. And yes, electric charge, all the elementary basic particles, these are basically elementary particles. And elementary particles mean your proton, neutron, electron. This I'll discuss with you in detail about protons and electrons specifically, because you have the whole basis of electric charge is electrons and protons only. But before we move further, just write down the gist of the syllabus for your knowledge if you want, and from here start noting it. This I think you should note down, so at least you will have an idea. Then note down the starting portion, then I'll discuss the later things with you. Written?
Yes, ma'am.
Fine. So yes, so this was what was the basic part we have been discussing. One more thing, just add one more point I forgot to tell you. So scalar quantity. So no need to apply any law, parallelogram laws. It's just a simple scalar quantity. Algebraically add all these quantities. They do not have any direction. Okay, this part is important, class. Minimum positive and negative charge that can exist in nature in free form. This means that there is a certain minimum value of charge that has to be present for charge to be happening into its existence. If the value is below this particular value, 1.6 into 10 to the power minus 19 coulombs, there is no existence of charge. Means charges start their value from this only. This number, no, 1.6 into 10 to the power minus 19 coulomb. The charges begin their existence from this term only. Means first one electron will be having this much amount of charge. Minimum one electron, only single electron. And obviously half electron, quarter electron does not exist. You have one single electron. So that single electron will be having this amount of charge. That is 1.6 into 10 to the power minus 19 coulomb. This much amount of charge. Below which no charge exists. Above which it exists. How will it exist? That we'll discuss. That we have a specific topic also under the properties also of it. So 1.6 into 10 to the power minus 19 coulomb is the minimum amount of charge that can exist in free form. So this actually, this value is valid for both electrons, valid for electrons and protons. So that's why this term, this number basically 1.6 into 10 to the power minus 19 coulombs, this is called as the electronic charge. And class, you have to remember this value at any cost. Otherwise, your whole question, whole method, or you can say whole effort for studying this lesson will go into vain. Why? Because this is a very basic thing which all of you should remember, as well as this won't be mentioned to you. This value is so basic that starting from today's class, that's the first class, first lesson, till the last class, last lesson, semiconductors, this value will be used. So it's not a part of electromagnetism, but still the value will be used. Throughout your entire first book, this value will be used. And this won't be specifically given to you in the exam paper also. You have to learn it, use it by yourself. Some values are there in your class 12 syllabus. Those values you have to remember. First one is this, electronic charge. Many a times, class, it can also happen that this value is not directly written as electronic charge. So at that time, it will be written as simply as this letter E. E means electronic charge. Wherever E is written, simply replace E with this number 1.6 into 10 to the power minus 19. Fine. For proton, now one question that can arise is protons exist, electron exist, both of these. So if a charge is mentioned, let's say 1.6 into 10 to the power minus 19, this amount of charge is given. How will you decide, how will you know it that this is for electron, this is written for proton? If nothing is mentioned, how will you understand it, whether it's for electron, proton? So best way is to put a sign to distinguish. For proton, it will become plus 1.6 into 10 to the power minus 19 coulombs. For electron, it will be 1.6 into 10 to the power minus 19 coulombs. So this will be plus minus both depending upon the nature of the charge, whether it's electron involved, whether it's proton. So class, I'm again repeating, learn this value properly, 1.6 into 10 to the power minus 19. And see, when we say no, an object is neutral, three states exist: positive, negative, neutral. Neutral means whatever amount of positive charges are present is the exact amount of negative charges present. 5 coulomb minus 5 coulomb, they'll cancel, neutralize. 3 coulomb minus 3 coulomb, they'll neutralize and you'll get a neutral object. Fine. So whatever, most of the objects in nature are neutral. If suppose if I'm able to touch the phone, I'm not getting any current. It means negative charges are not excess. There is no presence of excess electron. Electrons, protons, both are there. But what is happening? Amount of positive charges is actually getting equal to the amount of negative charges. Fine. So amount of positive charges is equal to amount of negative charges in a neutral body. All right. Now, how do we say a body is positive or negative? If do we add certain protons to make a body positive, or do we delete some electrons to make a body positive, or do we add electrons to make body negative? Like what is the basic phenomena for calling a body as positive or negative? So see, neutral you have understood. Equal amount of positive charge, equal amount of negative charge, they'll neutralize each other and the resultant body is neutral. For understand this properly, class, this is very important. Directly this topic is not asked in your exam, but a very significant role it plays in the understanding of the upcoming topics. Now see, when I talk about the nucleus, the innermost nucleus, this is nucleus present. Within this nucleus, neutrons are also present. Within this nucleus, protons are also present. Fine, these protons are present within this nucleus. All the protons, whatever amount of protons, these are present within this nucleus. Fine, protons are present here. What about electrons? Electrons are revolving around the nucleus in circular orbits. The details about it, the energy, I think some of the basics idea you already have from your class 11's chemistry. A rest of the details of modern physics, that we'll see when we'll reach the term 2 portion of it. But what is required here is, protons are held within the nucleus. These are the protons which are held within the nucleus, while the electrons revolve around the nucleus in their own spherical circular orbits. Now, two types of forces exist here. Two types of forces are existing over here. Carefully understand this part. One force is within the nucleus, that is holding the protons tightly. The protons are getting held by the nucleus with the help of tight nuclear forces. These nuclear forces are very strong. So protons are held within the nucleus with the help of nuclear forces. So first force that you're getting is other nuclear forces, which are holding all the protons tightly within this nucleus. These are very strong forces. Secondly, these electrons are also present. Now what will happen? So the electrons, these are held within the nucleus with the help of the second forces, which we have to discuss in detail in this lesson, that is the electrostatic force. Electrostatic forces. So electrons are held by electrostatic forces. Protons are held by nuclear forces. But still we haven't got any conclusion regarding a positive or a negative body. See, these nuclear forces are 100 times stronger than electrostatic forces. Their affinity is 100 times. The fourfold potential is 100 times than that of electrostatic forces. So when I talk about nuclear forces, they are almost 100 times stronger than electric force. So tell me one thing, by your analysis, if protons are held tightly, very tightly with the help of strong nuclear forces within the nucleus, and electrons are revolving with the help of weak electrostatic forces, which bond can break easily? Electrons or protons?
Electrons.
Electrons, of course, electrons. Why? Because electrons are held through weak forces. Protons are held through strong forces. So it's very difficult to remove a strong force, break a bond between a strong force of attraction, and quite easy for weak forces. So remember one thing, it's the transfer of electrons that occur from one body to another. It's just the transfer of electrons that occur. Protons do not move. It's not the addition of protons, it's not the deletion of proton, it's simply the addition or deletion, or simply in one term you can say transfer of electrons that occurs. So this bond is strong, so this remains intact. This is weak bond. So what happened? Transfer of electrons occur. Protons do not move. Now, one body will be eliminating the electron, right? If electrons are moving, suppose in this case only, this one of the electrons move. So the body from which the electron is moving, where the electron is actually moving and getting away, this body is called as positively charged body. So it's not the addition of protons that is making a body as positive, it's actually the deficiency of electrons that is making a body as positive. All right, if a body is positive, that is because of deletion of electrons, not addition of protons. Protons do not move. So deletion of electrons lead to formation of positively charged body, and the body that will now gain electrons, that will be termed as negatively charged body. And when electrons and protons both are equal, it will be termed as neutral body. This is the basic mechanism. I hope this is clear to both of you. Yes, no?
Yes, miss.
Oh, good. Note it down. Then you have the next topic as charging of electrons that I'll tell you. This is just a basic topic, but yes, class, this has a significance, this portion that we have just discussed. Note it from here, this you have written, note it from. Yes, it's the value of charge. It's the value that one single electron is holding. So one electron is having this value. So if two electrons are there, it will double. Tari don't about the forces. Actually, nuclear forces are included in your lesson nuclei, and electrostatic forces, you have a complete Coulomb's law for that. So that is a very separate and important topic. So that we'll discuss. Done till here, Aram and Tarif?
Yes, ma'am.
Okay. See what is meant by charging. This transfer of electrons that I have been mentioning, electrons get transferred. That is only termed as charging. So when I say different methods of transferring of electrons are there, it means I'm saying methods of charging are there. So charging simply means when a body is charged, transfer of electrons occur. Transfer of electrons or redistribution of electrons occurs. So for negatively charged body, it gains electrons. Now see, when a negatively charged body is gaining electron, the associated mass will also be increased. See, I'll show you this. How the associated mass will be increased. Charging is a body can be charged by transfer or redistribution of electrons. And for negatively charged body, it gains electrons as well as the mass of the body increases. See how, for example, I have this first case. 4 electrons are present and within the nucleus, 4 protons are present. So net charge on this body A, 4 protons, that is 4 into electronic charge. E means 1.6 into 10 to the power minus 19. This is not meaning electrons only. E when I'm writing, I have told you, electronic charge symbol is 1.6 into 10 to the power minus 19. So 4E and minus 4E for all the negative charge. So this cancels and this becomes 0. This is the mass of this body, AMA. Come to the second one. How many protons are there? 4 protons are there. And how many electrons are present? 5 electrons are present. So this time it becomes 4 protons, that is 4e, minus 5 electrons. So that becomes minus e. See, by calculation also you can see 1 extra electron is present this time. This electron has been added. So this additional new electron, this is now making the entire term as negative, minus e, right? This is making it as minus e. So 4e minus 5e, that is making it as minus e. So see, if the masses of all the 4 electrons were 4m, now mass of all these electrons will become 5m. It means mass has increased. Similarly, let's say I have removed one electron. I've thrown 1 electron out of this. So this is the third case. Now see what is the charge. 4 positive charges minus 3 negative charges. That is 1 single positive charge. This is how a body has become negative. And what will be the mass this time? Mass will be 3m. So see, mass has decreased from the original mass. 4m, 5m, 4m, 3m. This is what is the basic mechanics of your positive and negative charges. Fine. Then you have basically 3 methods of charging exist. Charging by friction, charging by conduction, and charging by induction. Friction, conduction, induction. Then your whole entire charge topic will be completed. Note it down, note this page.
Miss, is the first case neutral?
Yes, Tarif?
This is the first one neutral charge.
First one?
Yes, Miss, the first one. At 4
Yes,
even.
this is neutral. Yes. This one, first one is neutral because 4 electrons are present, 4 protons are present. So we are having this body as neutral. But for positive or negative, electrons have to move. So for this, from the second case, you can easily figure it out. Electron, as soon as the electron gets added, the negative charge increases, body becomes negatively charged, and mass also increases. So I'll write it down. I think it's better. This is neutral. This is negative. And this is positive. Yes, class. Now, charging by friction at least. Let us complete charging by friction. See, charging by friction means what? Frictional force we have studied in class 11. So frictional force came into action when two irregularities were, they went past each other, right? So when two bodies are rubbed, then also transfer of electrons occur. And that transfer of electron which occurs due to friction, we call it as charging by friction. Fine. So basic concept no in this which gets applied is work done. Work done against frictional force. So while rubbing, what happens? See, while you are rubbing two objects or they are getting in contact and they are getting rubbed, while rubbing, heat energy generates. Heat energy generates, and this heat energy leads to the transfer of electrons. Fine. This leads to transfer of electrons. So positively charged loses electrons, its mass decreases. Negatively charged body gains electrons, its mass increases. Right. So this is one example where rubbing example is there. Before rubbing, this is the state. So this is body A, this is body B. So what is the charge on this body A? See, 4 electrons and 4 protons, that is 0, neutral body. Similarly, for B also, 5 electrons and 5 protons. This is also making this into a neutral body. Now, one condition I give you. I give you a condition that in B means in this body, in this one, in B, electrons are strongly bonded as compared to A. One was electrostatic force and nuclear forces, which I've told you from which nuclear forces are strong. But if I compare two weak inter-electronic forces, then electrostatic forces, out of these two, some will be weak. So out of A and B, I tell you, I give you a condition. This is just a random example, random condition that I am giving you, that electrons are strongly bonded as compared to A. If electrons in B are strongly bonded, so it is easier to remove electron from A or B if this is the condition.
A.
A, yes. So electrons become easier. It is easier to remove electrons from A. So see, after rubbing, what happens? Let's say this was A. This is B. So one electron, the fourth electron has actually moved into this. So this is what happens when you are rubbing. What is the deciding component? What will decide whether electrons will move from A to B or B to A? That depends upon the affinity. Since it was easier to remove electrons, easier to remove electrons in A than B. And one more thing, total charge remains constant. Means initially there were 4 here, 5 there, 9. Now also there are 3 here and 6 there, 9. Net charge is still 9. Just two theoretical points you have to remember. Yes, conservation. These are conserved. this is not very important class, but by chance, since it is mentioned in your NCERT, that's why these two examples I have mentioned it separately. So I think it would be beneficial only if you remember these. Glass rod and silk. If you take a glass rod and suppose you rub it with a silk cloth like this, you're rubbing this with silk cloth. All right. So which will acquire positive, which will acquire negative? These are so many objects. How much can you remember? So for that, just remember this part for glass rod. When glass rod and silk are rubbed past each other, silk is going to acquire negative charges. That means electrons are going to move from glass rod to the silk cloth. Fine, electrons are going to move from the glass rod to the silk cloth. Means making the silk cloth negative, being themselves as positive. And similarly is the case for wool and plastic. When let's say this is a plastic rod, this is rubbed against some wool, winter wools which we have. So plastic is going to acquire negative charge this time. It is going to acquire electrons and is going to become negative, while the silk cloth will become negative. A wool cloth will become positive. So how do we know this? This is actually by convention. By convention, these have been going. So it can be given to you in theoretical questions, because in previous year board exams, if you see where conceptual questions were asked earlier, very earlier. So there also this has been mentioned. So this occurs after they are rubbed. This is what is simply meant by charging by friction. Note down this part as well. And when you're done, do text me done. Okay, if you've completed, then you can leave. Tomorrow we'll continue the rest of the portions of methods of charging. All right. Revise it and come. Okay, thank you so much, class.
Thank you.
For heat, so heat basically allows becomes a medium for electrons to travel. So when heated environment is there, so electrons get a medium to traveling. Then you have in detail about how heat and electrons and the movement of electrons are related in current electricity. You have full detail about it. All right, Tari.
Okay.